Yes, good morning. In the last lecture, we seen the unit number 2. Unit 2, vector integration. In that, specifically we have seen that is line integral, and I explained this line integral like this, that is integration f dot dr, f dot dr, it is as what it is, this is line integral. So now I would like to make another form. So this also you can write integration f dot dr by dt into dt also you can write. Okay, in these two forms we can write. Here, if f is equals to f1i plus f2j plus f3k, where f1, f2 and f3 are functions of x, y and z, and x, y and z, and if r is equals to xi plus yj plus zk, then dr is I dx plus I dy plus I dz, that we have seen in the last class. Then what about f dot integration of f dot dr is? Okay. F is there, f1i plus f2j plus f3k, and dr is I dx plus j dy plus plus I, it is j, sorry, it is k, I dx plus j dy plus k dz. Then here we'll get f1i plus f2j plus f3k dot I dx plus j dy plus k dz. Okay, that means how one can write, which implies that integration f dot dr over a curve C it is. Okay, it is over a curve C, so we can write like this: over a curve C is equals to integration over a curve C dot product of two vectors that we know, that is f1 dx plus f2 dy plus f3, that is dz will get. Okay, so this is a simplest form, or else this is another form of what that is line integral. Okay, either you can use this or you can use this. Okay, so according to what your requirement. That means here actually we cannot use this one, ultimately so we'll get this form. So this form will be solving in the example. Okay, so now I'd like to go for examples. So now so we'll go to examples. Yes, so examples. Example number 1. So I'll take up here. Okay, so if f is equals to 5xy minus 6x square I, 5xy minus 6x square I plus 2y minus 4xj then evaluate integration over a curve C f dot dr along the curve along the curve C in xy plane, along the curve C in xy plane, y is equals to x cube from the point 1 comma 1 to 2 comma 8, from the point 1 comma 8 to 2 comma 8. Okay, so this is a example, right? Now what they have given, we'll see. F they have given, okay, F is there, so I, J, K is not there. That means what? Z component is not there. That's why this particular vector or we can say vector point function, which will be lying in a xy plane. So therefore here curve C they have given. Curve C is what that is? Y is equals to x cube. From which point to which point? From 1 comma 1 to 2 comma 8. 1 comma 1 to 2 comma 8 means what? Along x axis x equals to 1 to x equals to 2, and along y axis y is equals to 1 to y is equals to 8. Okay, so now I would like to solve this example. Let f is equals to, rewrite it, so whatever they have given, for u xy minus 6x square I plus 2y minus 4xj, and call it equation number 1. And now we know that what is dr, okay? What is dr? R is xi plus yj plus zk. So therefore dr is what? That is I dx plus j dy plus k dz. Okay, already you know this is f1, this is f2. Okay, so therefore here I have written in a what that is in a space. So if you want to write it in a what that is plane also, the plane xy plane, then this k dz will not be there. But just to take it in general we'll take. So now what is, therefore f dot dr is equals to, as you know, okay, the components of these two will be, that's what that is multiplied. So therefore what you will get, for u xy minus 6x square, this is dx, plus here this will be 2y minus 4x into dy. For this k, actually kth term is not there means what? Kth coefficient is not there means what? That is 0. So therefore 0 into dz is, that is 0, leave it. So therefore this is your f dot dr. Okay, so what we need to calculate, that is integration over a curve C, f dot dr we need to calculate, and f dot dr is this much, and now I'll be calling it as what? That is equation number 2. So now I'd like to take this equation, this curve. So what is the curve they have given? Okay, so given curve C is y is equals to x cube. Differentiate this with respect to x. What you will get? That is dy by dx is equals to 3x square. Dy by dx is equals to 3x square. Make it into only dy. Okay, so dy is equals, that means dx we have to send it to, that is RHS. Then dy is equals to 3x square dx you will get. 3x square dx you will get. Guys, you can see here, actually this whole term 2 is depends on x, y, dx, dy. Now by taking that particular what equation 2, you cannot integrate. So therefore you have to convert this whole equation 2 either in terms of x or in terms of y. Okay, that is left to you. Either you have to convert this whole what equation 2 in terms of x or in terms of y. So therefore here y value is there. Y value is how much? That is x cube. So that you can replace wherever y is there, you can replace y is equals to x cube. Okay, dx is there, not to worry, because dx is what that is in terms of x is there. Here again y is there, you can replace y by this, and here dy is there, dy will be replaced by this. Then if you replace like that, then this whole term, this whole the LHS term, RHS term of equation 2 becomes in terms of x. So therefore, after this, so what we need to check is, if you are converting this in terms of x, if you are converting this whole equation to in terms of x, then from where to where that your x is varying. You can see here they have given the point 1, 1 to 2, 8. This is first is x component, this is y component. So therefore x is running from x equals to 1 to here x equals to 2. So therefore x is varying from x equals to 1 to x equals to, that is 2. And if you convert this whole thing in terms of what, that is y, then y is running from y is equals to 1 to y is equals to 8. One can very easily understand. So now what I'll do is, given points are 1, 1 and 2, 8. Therefore x varies from x equals to 1 to x equals to, that is 2. So therefore by line integration, what is that? Integration over a curve C, f dot dr is equals to, okay, f dot dr already we have found here. So therefore integration over a curve C, that is for u x y minus 6x square into dx plus 2y minus 4x into, that is dy, okay, into dy. So now everything is there. That means what, we have to replace y by x cube and dy by this much, and x will be varying from x equals to 1 to x equals to 2. So therefore integration over a curve C, f dot dr is equals to integration. I am converting this whole thing in terms of what, that is x. So therefore I'll be writing, that is limits as x equals to 1 to x equals to, that is 2. Then now for u into x you have to keep as it is, but what is y? Y value is x cube. Right here x cube minus 6x square, okay, minus 6x square into dx plus 2 into y value is again, that is x cube minus 4x into, what is dy? Dy value is 3x square into dx, 3x square into dx. Now elaborate this, which is equals to integration from x equals to 1 to x equals to 2. So 5x into x cube, 5x raised to 4 minus 6x square, dx is there, here is also dx is there. So we'll take dx common, then 2 into x cube is plus 2x cube, this is minus 2x cube into 3x square. See, 2x cube into 3x square, it is 6 times x raised to 5. Next minus 4, so minus I'll keep first, minus 4x into 3x square, that is minus 3 4s are 12 into x cube, okay. So now here it is, that is dx. So you can see it is x to the power 4, this is x to the power 5, this is x cube, this is x square. So first if you want you can rearrange them. First I'll write 6x to the power 5 first, next plus 5x raised to 4, next minus 12x cube, after that last one is minus 6x square, okay, into dx. Now integrate it. Integration of 6x raised to 5 with respect to x is 6x raised to 6 divided by 6 plus 5x raised to 4 is 5x raised to 5 by 5 minus 12x cube is 12x raised to 4 by 4 minus 6x square is 6x raised to 6x cube divided by 3, and the limit is from x equals to 1 to x equals to 2. So now this 6 get cancelled, 5 get cancelled, 4 1s are 4 3s are 3 1s are 3 2s are. So here you will get, that is x raised to 6 plus x raised to 5 minus 3x raised to 4 minus 2x cube. then here it is x equals to 1 to x equals to 2. And now integration over a curve C, f dot dr is equals to, now put upper limit, that is 2 to the power 6, 2 to the power 6 plus 2 to the power 5 minus 3 into 2 to the power 4 minus 2 into 2 to the power 3. So this is for upper limit, and for lower limit it is 1. So anything to the power 1 is 1 only. 1 plus 1 minus 3 minus 2, then which is equal to 2 to the power 6, 2 to the power 5 is 32, 2 to the power 6 is 64. This is, yes, 64 plus 32 minus 2 to the power 4 is 16, 16 3 is a 48 minus 2 to the power 4, that is again it is 16 minus, this is, these two get cancelled, it is minus of minus, this is plus 3. Okay, so that is nothing but 64 here, 64 plus 32, 64 plus 32, it is 66, 66, 96. Okay, then the final answer, is, that is 35. Okay, so here this will be 35. Integration over a curve C, f dot dr is 35. Okay, like this, so we can solve examples on, that's what, the line integral. Okay, this is the first example. So next I'll go to another example. Okay, so let me take next example. Example number 2, evaluate the line integral, evaluate the line integral integration over curve C, x square y dx plus x minus z dy plus xyz dz, where C is the parabola, y is equals to x square in the plane z is equals to, 2 from a 0, 0, 2 and b 1, 1, 2. Okay, this example is as like the previous one, but here in the previous example this dz term was not there, but now in this particular example this dz is also there, but for that particular z they have given z is equals to 2. That means what? The plane z is equals to 2. Plane z is equals to 2 means what? Plane z is equals to 2 means what? It is a plane parallel to, that is xy plane. Parallel to xy plane is, for example, if you consider, so this has x axis, this has y axis, and that has z axis, then this floor is that is xy plane. then parallel to this floor is z is equals to 2 is a plane which is parallel to what? That is xy plane. That means it will cut z at x equals to, it will cut z at z is equals to 2. So therefore, so little bit above the what? That is surface. So therefore, so this will be the what? That is z is equals to tooth plane. Now they have given z is equals to 2 here, and point they have given a is equals to 0, 0, 2 to b is equals to 1, 1, 2. For example, if you convert whole what this line integral in terms of what x, then x is varying from x equals to 0 to x equals to 1, and if you convert this whole thing in terms of y, then y will be varying from y is equals to 0 to y is equals to 1, and z is what? That is constant. So therefore z will not be varying because they have given z is equals to 2 as a plane. So now if you see the solution of this particular example, so we have very less to do with this particular example because there is no need of what? Finding f dot dr. Okay. Yes. So now we'll see the solution. Let integration over curve C f dot dr is equals to integration over C x square y dx plus x minus z dy plus xyz dz. Okay, we call it equation number 1. Okay, so now given curve C is y is equals to x square, then what is dy by dx? Dy by dx is equals to 2x. So therefore dy is equals to 2x into that is dx. Okay, so this is dy. So now also given that z is equals to 2, then what is dz? Z is a constant, so therefore what is dz? Dz will be 0. Okay, so obvious because z is a constant, so therefore its derivative with respect to any what the variable will be 0, so therefore dz is equals to 0. So now I'll take up I'll put that is y is equals to x square here in this equation and z is equals to 2. I'll put y is equals to x square, z is equals to 2, dy is equals to this much and dz is equals to 0. Then this whole term, this whole equation 1 will be converted in terms of what that is x. So therefore here I'll write therefore equation 1 becomes integration over C f dot dr, or this whole thing also you can write it. Yes, then keep x as it is. Sorry, here one more term I have not written. Given point, okay, given points are a 0, 0, 1, sorry, a 0, 0, 2 and b that is 1, 1, 2. Therefore x varies from x equals to 0 to x equals to 1. Okay, so now here I'll write x is varying from x equals to 0 to x equals to 1. Then now next is x square, keep as it is. Y is there, y value is how much? That is x square. So here you can write x square into that is dx. Next, plus x will be as it is, z value is 2, x minus z is there, so therefore z is equal to 2, therefore z minus 2, and the dy value is how much? 2x into that is dx. Next, last one, plus x y z. X will be kept as it is, y is equals to x square and z is 2 and dz value is 0, okay, because dz value is 0. Z is constant, so therefore dz value is 0, therefore we'll put that dz is equals to 0. Then integration from x equals to 0 to x equals to 1, x square into x square, x to the power 4 into dx, plus 2x into x, that is 2x square, minus 2 into 2 4, this is 4x into that is dx, plus x into x square, x cube into 2, that is 2x cube, but it is 0, this whole term is 0, so therefore we will write that is 0. Now which is equals to integration from x equals to 0 to x equals to 1, x to the power 4 here, x to the power 4 plus 2x square minus 4x into dx, because dx in this dx is there in this term and also in this term, so therefore I have taken dx as common. So now integrated, that is x to the power 4, integration of x to the power 4 with respect to that is x, so we'll get x to the power 5 divided by 5 plus 2x cube divided by 3 minus 4x square by 2, and x is equals to 0 to x equals to 1, 2 ones are 2 twos are, so that means, so now put upper limit, that is 1 by 5 plus 2 by 3 minus 2, and for lower limit that is 0, okay. So therefore by taking a LCM, the LCM of 5 and 3 is that is 15, so therefore here it will be 15, this is 3, this is 2 5s are 10 minus 15 2s are 30, okay, this is 30. Then the integration over curve C, f dot dr is equals to this is minus 20 minus 17 divided by that is 15, so this is the answer, minus 17 by 15. So this is a second example. So similarly, so I'll go for one more example and later I'll change my concept to what that is surface integral. So one more last example, so we'll solve on this, okay. So now, okay, so this example is little different. Here they said find the total work done by the force field, okay, force field they have given along some curve they have given, and some point t is equals to 1 to t is equals to 2 also they have given, okay. So we'll see this is a little different example than what the previous two. So now example number 3. This third example, find the total work done, find the total work done by the force field 3xyi minus 5zj plus 10xk along the curve x equals to t square plus 1, y is equals to 2t square, and z is equals to t cube from t is equals to 1 to t is equals to 2. So this is a simple example, but little change little change is there. So if you compare this particular example with the what that is the previous two examples, you can see here they are not given only single curve. Okay, they have given the curve in terms of that is parametric form. That means there is no relation between x and y, x, y and z. Okay, here they have given the relation in terms of what some other parameter t, that is x is equals to t square plus 1. So therefore t is the same parameter. Okay, so how that x is depending on the t, and here y is equals to 2t square. Okay, that y is also depends on t, and here z is t cube, that z is also depends on that is t, and t is equals to 1 to t is equals to 2. In the previous case what we did is we converted the remaining two what that is variables y and z in terms of x. Okay, and in this particular example we are converting all the three variables x, y, z in terms of t. So therefore will be so that we can solve the example. So now for this particular example, so we see the solution. Let what is f is equals to, that is what force field they said, and here they are finding a work done by this particular force field. Okay, work done in the first class only I explained what do you mean by work done. Work done is what that is line integration over a curve C f dot dr. So therefore that will comes under what that is line integration. So therefore f is equals to 3xyi minus 5zj plus 10xk. Call it equation 1. Okay, next what is dr? Dr is equals to I dx plus j dy plus k dz. Therefore what is f dot dr? F dot dr is equals to I component, here is 3xy, here it is dx, that is 3xy dx, here it is minus 5x into 5z dy, and here it is plus 10x, that is dz. Okay, so now you can call it equation number this 2. So this is your f dot dr, right? So next, given that x is equals to t square plus 1, y is equals to 2t square, and z is equals to t cube, right? So now differentiate these all 3 x, y, z with respect to t, then we'll get dx by dt is equals to 2t plus 0, so therefore 2t, and now here dy by dt is equals to, that is 4t, because 2t square derivative is 2 into 2 4t. Next dz by dt is equals to, this is 3t square. If you rewrite them in terms of dx, dy, dz, then you will get dx is equals to 2t dt, dy is equals to 4t dt, and dz is equals to 3t square dt. Okay, and also given that from where to where t is varying from t is equals to 1 to t is equals to 2. Also given that t varies from t is equals to 1 to t is equals to 2. Okay, so this much they have given. So now here we'll write work done. Yes, the work done by the force field 1. What is that force field? Force field is this here. Force field 1 is integration over f dot, that is dr, over a curve C. Okay, that means what is f dot dr? F dot dr is here. Okay, so 3 3xy dx minus 5z dy plus 10x dz. Okay, so now you have all the terms. What is the value of x, value of y, value of z, what is dx, dy, dz, and from where to where t is running. So therefore here we are converting this whole term in terms of what that is t. So therefore t is running from t is equals to 1 to t is equals to 2. 3 into what is x, t square plus 1, y is 2t square, and dx is 2t dt, 2t dt, plus next minus 5u into z, z value is t cube, dy value is 4t dt, 4t dt, next plus last one 10x, 10 into x value is t square plus 1, t square plus 1, and dz value is 3t square, 3t square dt, okay, which is equals to integration from t is equals to 1 to t is equals to 2. So now here you can see 2 into 2, 4, 4 means 4 into 3, that is 12. So 12, here it is t square, here it is t cube, 12 t cube, 12 t cube into t square, that is 12 t raised to 5. Then 12 t cube into 1 is 12, that is t cube, and dt is common, so we'll write it last. So now 5 into 4, that is 20, 5 4 is 20, t into t cube is t raised to 4 minus 20 t raised to 4. Next here it is 3 into 10, 10 into 3, 30, 30 t square into t square plus 30 t raised to 4 plus 30 t square. Lastly here it is dt. Okay, so now rewrite that. T is equals to 1 to t is equals to 2. 12 times t raised to 5, I have to write as it is. Here it is minus 20 t raised to 4 plus 30 t raised to 4. That means plus 10 t raised to 4. And here it is plus 12 times t raised to 3. And here this will be plus 30 times t square into dt. Now integrate. So integration of 12 t raised to 5 with respect to t is 12 t raised to 6 by 6 plus 10 t raised to 5 by 5 plus 12 t raised to 4 by 4 plus 30 t raised to 3 by 3, and here it will be t is running from t is equals to 1 to t is equals to 2. So therefore integration over curve C, f dot dr is equals to 6 ones are 6 twos are 5 ones are 5 twos are 4 ones are 4 threes are 3 ones are 3 tens are. So then here we'll get, that is 2t raised to 6, 2t raised to 6 plus 2t raised to 5 plus 3t raised to 4 plus 10 t cube, and t is equals to 1 to t is equals to 2. So which is equals to, put upper limit, 2 into 2 raised to 6 plus 2 into 2 raised to 5 plus 3 into t raised to 2 raised to 4 plus 10 into 2 raised to 3, and minus for lower limit it is 2 into 1 2 plus 2 into 1 2 plus 3 into 1 3 plus that is 10 into 1, that is 10. Okay, so now which is equals to, what is common in this, 2 raised to 3 we can take common, 2 raised to 3 in this term we can take 2 raised to 3 as common. Then here we will get 2 raised to 3 2 raised to 4 will get, here we'll get 2 raised to 6 means 2 raised to 3 plus 3 into 2 plus this is 10 minus 2 plus 2 4, 4 plus 3 7, 7 plus 10, that is 17, which is equals to 2 raised to 3 is 8, you can write here 8, 2 raised to 4 is 16 plus 8 plus 6 plus 10 minus 17, that means 8 into 16 plus 8, yes, 16 plus 8, 24, 24 plus 6, 30, 30 plus 10, 40, 40 minus 17, 8 4 is 32, 320 minus 17, the answer is 303. The final answer is F dot dr. Therefore, total, what they asked, find the total work done by the force field is 303. Therefore, total work done by the force field 1 is 303. So unit that is depends, because here unit is not given, so therefore 303 only I'll write, okay, or 303 unit also we can call. Yes, so this is how one can solve the examples on this line integral. Okay, I have shown I have solved 3 examples consecutively on this line integral, and you people have 2 more examples. Okay, that is first and fifth example in your notes. You can see the notes and you can very easily understand those 2 examples. Okay, after this, so now I'll go to next concept in the same unit. So we see that is line integral. Now I'll go to that is surface integral. Okay, now next concept is that is surface integral. Okay, you people seen the vector integration over a curve. Now the same vector integration over a surface. Okay, so what is that and how one can represent? So in a simple way I'll show you, that is integration over a surface. Yes, okay, the previously we say that's what integration over a curve C, and now we are saying integration over a surface. Yes, F dot n cap ds. So this we call that is surface integral. This we call that is surface integral. Here F is that, you know, that is what vector field, or else we can call vector point function. N cap and ds means what? Okay, n cap is that is unit external normal vector to the surface. Yes, surface yes means what? Guys, you can see that is sphere. Okay, the sphere will be having what? Surface over it. Okay, so on that surface whatever ds we are representing, for example, just you can consider that's what hemisphere. Okay, you can consider hemisphere. This is the surface. Okay, and here if you consider a small, this whole thing is what? That is surface. Then ds means what? That is a small element on the surface. So how it will be like this? Might be it is okay. So this is what actually ds. Okay, this is a surface element. Okay, a small, we have considered a small element on the surface. For example, so this is the surface. Then we have considered very small element on the what? That is surface. So for instance, if you project this particular what? if you project this particular surface element on any of the planes, then what you will get? So we will get projection of that surface element ds over, that is xy, we will get. Okay, the projection of the surface element xy we will get. And now what is this n cap? N cap is a unit external normal we are saying. Okay, so if this is what the surface point, then this is what that is unit. Unit means that its magnitude should be unity. Magnitude is 1. So unit normal, external normal vector, okay, that should go outside the what, that is surface, not inside the surface. Okay, it should go out of the surface. That's why we can call it as what, that is unit external normal vector, and that is n cap. Okay, so this particular what the integration is there. So this particular integration will be calling as what, that is surface integral. So now we need to see whether it is possible to do surface integration by what, having these particular what the data. So it is not possible, because we need to project this ds either on xy plane or yz plane or zx plane. So that what we will get, that I need to give in the that's what notes. So now here I'll give you those important what, that is remarks over surface integral. That is important remarks Okay, that is first one. If R is the projection of surface S on xy plane, if R is the projection of surface S on xy plane, then if R is the projection of surface S on xy plane, then ds can be written as dx dy divided by, that is n cap k. Okay, what is k? K is a unit vector along z axis. K is a unit vector along z axis. Okay, next, similarly, if R is the projection of surface S on yz plane, then what is ds? ds is equals to, in yz, on yz plane we are projecting, so therefore dy dz will be writing divided by, here that is modulus of n cap dot, you can see j is for y, k is for, that is z, then remaining is what, that is I, n cap dot I. Similarly, last one, that is if R is the projection of surface S on xz plane, then ds is equals to dx dz divided by modulus of n cap dot j. Okay, therefore surface integral can also be written therefore the surface integral can also be written as that is integration over a surface S f dot n cap ds is equals to if you project it on xy plane, then we'll be writing it as double integration over a region R. R is what? That is the region on the, that's what, xy plane, or region in the yz plane, or region in the, that is zx plane. Okay, that is zx plane. So like that. So double integration f dot n cap into dx dy divided by modulus of n cap dot k, or okay, if you project it on, that is xy plane, or if you project it on yz plane, then integration over f dot n cap ds over a surface S is equals to double integration over a region R. Okay, that's what we are, but we are projecting it in, that is yz plane. F dot n cap, that is yz plane, means dy dz divided by modulus of n cap, that is I. Or if you project it on xz plane or zx plane, then integration over f dot n cap ds over a surface S is equals to double integration over a region R, that is f dot n cap dx dz divided by modulus of n cap dot j. Okay, so like this, so we can evaluate, that is surface integral. As I told you, only by taking what this ds, is it possible to evaluate the surface integral? Absolutely no. You have to project the given surface either on xy plane or yz plane or zx plane. If you project it on xy plane, then f dot n cap ds, okay, that's what surface integral of what, that is f, is like this. If you project it on yz plane, then surface integral will be like this. If you project it on zx plane, then your surface integral will be like this. Okay, and here whatever the double integrations are there, so you need to what, allocate, that is limits for, if you project it on xy plane, then you have to allocate, that's what, the limits for x and y. Okay, and here you have to allocate limits for y and z, and here you have to allocate limits for that is x and z. So like this, one can very easily evaluate, that's what, the surface integral. Yes. So in the next class, so we'll see examples on this surface integral, and next we'll go to volume integral.